Today we're going to learn our next transformation, which is called a reflection. Who thinks they know what a reflection is?
Basically, it's from the same place on the top.
So, have y'all ever looked in a mirror? What happens? You see yourself, but it's backwards, right? It is a flip. It flips the image backwards. A reflection is a flip. The line of reflection, there's two ways you can do a reflection on a coordinate plane. You can flip across the x-axis. Everybody should be writing. Or you can flip across the y-axis. There are two types of reflections. A reflection across the x-axis and a reflection across the y-axis. So I want everybody to look at the image right here in the corner. Which shape is the original shape? How do y'all remember? How do you do it? How do you know? It doesn't have the dashes. So this is the old. This is the what? So you guys tell me, what did they flip this shape across?
The y-axis.
Really? Everybody look at it. It flipped across this line, yes? So that is a reflection across the x-axis. Did everybody hear that? That is a reflection across the x-axis. What if I would have flipped it across the y-axis? Where would this one have gone? Right here. Does that make sense? Yes or no? Okay. Did it change size? No. Did it change shape? No. Are its angles different? No. The only thing that's different is where it's located in your view. So if y'all look at my hand, right now my palm is up. When I flip it, now my palm is down. It's still the exact same size, exact same shape, but your view of it changes, right? All right. There are two rules for you to learn. A reflection across the x-axis and a reflection across the y-axis. There is no number to plug in today. So let's look at why these rules are the way they are. So everybody look along with me. Right here, I have B at +4, +1. Does everybody agree? Now look at the new B. It is at what? +4, -1. So when we reflect across the x-axis, the x stays the same. Everybody look, did the 4 stay the same? But the y became opposite. I'm going to say it again. When you reflect across the x-axis, the x, I didn't mean to put a little negative, that's a +4. The x stays the same, but what happens to the y? It becomes opposite. So if it's negative, it'll become positive. If it's positive, it'll become negative. Look at the rule for reflections across the x-axis. It says you take your x and y, and the x stays x, but the y becomes opposite. So look at the rule for reflections across the y-axis. The y stays the same, but the x becomes opposite. Now, today's lesson will be so easy because your answers will be one of those. Yes? Why is this hard on the STAR test? Because you're not going to have the rule in front of you. You have to memorize these rules or understand how to figure them out. So we will work hard on memorizing them. Okay? And the way I memorize these is I say when I reflect across the x-axis, the x stays the. When I reflect across the y-axis, the y stays the. And then the other ones become opposite. All right, let's look at some examples. They want you in example 1 to reflect this shape across which axis? So I want you to highlight or just draw a line across the x-axis. So everybody look at point R. From the x-axis, how high up is point R? Guys, look at the dot. See it? So go to the x-axis, and from there, if I want to flip it, I'm just going to go down 2. So this will be the new R. It's going to be at the same spot on the x-axis, but instead of up, it will be down. Look at point S. From the x-axis, it's on the 3, yes? But how high up is it? So stay on 3, and instead of being up 4, we're going to go down 4. 1, 2, 3, 4. This is my new S. All right, look at point Q. On the x-axis, it is at 1, but instead of being up 4, it's going to be down 4. That is my new Q. And I have one more point to go. Here's point T. On the x-axis, it is at 2. It's going to stay on 2, but instead of being up 5, it's going to be down 5. And then I just connect my dots, and I just drew a reflection across the x-axis. Now it wants me to write the rule. Now, honestly, you could just go up here, and it's going to be this rule for a reflection across the x-axis, right? So you say, take your x and y. When you reflect across the x-axis, the x stays the, and what happens to the y? It becomes opposite. That's it. I'm going to say it again. When you reflect across the x-axis, the x stays the same. The y becomes opposite. So now we're going to take that same shape, and what are we going to do this time? We're going to reflect it across the y-axis. So I'm going to take my highlighter, and if you don't have a highlighter, just take your pencil and highlight the y-axis. We are going to flip it across the y-axis. So it's going to go from left to right. So everybody look at point R. Point R is at the 2 on the y-axis. So instead of being right 2 from the 2, we're going to be left 2. And I'm going to label that my new R. All right, the Q is right here on the 4 on the y-axis, but instead of being right 1, it's going to be left 1. That is my new Q. My S is at the 4 as well on the y-axis, but instead of being right 3, it's going to be left 3. And my T is right here at the 5 on the y-axis. Instead of being right 2, it's going to be left 2. So here is my shape reflected across the y-axis. Now it wants us to write a rule. The rule for reflecting across the y-axis says take your coordinate. What stays the same? The y stays the same. The x becomes opposite. Easy? Okay, let me ask you some questions. When you reflect a shape, do the angles get bigger? No. When you reflect a shape, are the sides proportional? They are the exact same. They are not proportional. They are the exact same. What's the word that means the exact same in math? Congruent. One way the STAR test likes to word it is they say it preserves congruence, meaning it keeps it the same. Okay? So your assignment is going to be found on the Google Classroom, and then I will pass out an answer document like always, and then you'll come get it checked with me.